My name is Rinehart. It's my distinct pleasure to take time out of your Saturday and talk a little bit about ChaoSlingr, the role of security and chaos engineering. It's sort of a novel idea that the folks that I work with, United Health Group and Optimum Technology, have really found fascinating and great work. Also, we found some interesting results and applications in this new field of testing. So ChaoSlingr is, in general, is the idea of introducing security-based chaos testing. Security by nature is chaotic, from the way the attacks work to the way our assumptions work around the preventive controls we've put in place. What our goal is to drive out failure and build software that is rugged, that is resilient, that is anti-fragile. Software that can withstand harm and actually grow better through harm. Because if you think about it, humans, as well as systems, grow better with failure, whether it be a security incident or whether it be existing type of testing technology. When we find out we have failure, that's how we get better. Humans are the same way. When, in order for our bodies to get stronger, they have to endure failure. Think about the way exercise works and working out. It's very similar. And that is the idea that we're proposing today and talking about. We're also going to talk about a tool that's been developed, ChaoSlingr, in this space. It's an open source tool. And you'll be, as soon as we're done here, or even during the presentation, I welcome you to go to github.com, type in ChaoSlingr, and you'll find the code readily available there. So ChaoSlingr is a security and chaos engineering tool focused primarily on the experimentation on AWS infrastructure to bring system security weaknesses to the forefront. We traditionally put a lot of emphasis around preventive security controls and the concepts of defense in depth. But our mission is to challenge that concept. Defense in depth and layered security does not mean that there isn't a path all the way through the layers that you put in place in your security. So not only do we, as part of developing this, it has really challenged my own thinking about the way I have presented security in the past. Is that we put all this emphasis around putting a firewall there, putting all these different things, from a security perspective in play. But how often do we actually challenge those assumptions? How often do we instrument the control plane? How often do we throw failure at the firewall to see if the firewall caught it, or the configuration management system, or whatever tool you want to pick? We spend so much time assuming those preventative controls we put in place work, and we rely on the fact that the defense in depth is a principle, and that is not always true. And we've seen that with some of the we'll go over some of the data breaches we've seen recently and how this actually relates to that. So let's dive a little bit deeper here into the beginnings. So today we're going to talk just a little bit, just to give you a backdrop. We're going to talk a little bit about chaos engineering. It's helpful to understand the basics of where chaos engineering began, the principles behind it, and how security fits right in there with it. I'm also going to talk a little bit about the design and the open extensible framework for chaos experiments with ChaoSlingr. I'm also going to talk about what's next, because this is not just a presentation on a tool that we developed. It's a tool that we envision the world to develop together. We open sourced it because we'd like it to be a community-driven engineering effort. So here's a little bit about me. My name is Rinehart again. I am the Chief Enterprise Security Architect for United Health Group. United Health Group is somewhat of a large enterprise, and we'll talk about that. Here's some of my contact information. I'll be sharing these slides later, so you'll be able to get this later. In this picture you see on the right, John Willis, one of the authors of the DevOps Handbook, he's not sitting on my lap. So Jeff Williams in the middle there is the founder of OWASP, and he really is that tall. So United Health Group faces complexity like I had never seen in my career. I've worked at major government agencies, from aerospace to defense, to you name it. And I will tell you that United Health Group, I've never seen such complexity, but we're also such success in that complexity. And so just to give you a little backdrop, we're roughly 360 companies plus. 100 different legal entities. Our portfolio of applications is anywhere from 8 to 12,000 applications. We have a massive number of developers. Security, we have over 1,000 security professionals. Our cloud journey is somewhat mixed. Healthcare is challenging for healthcare to be in the cloud, but we are leading and working through those challenges. The large size of the company and the complexity of it means that we have a very diverse technology portfolio, everything from mainframes to microservices. So let's talk about chaos engineering. So the definition of chaos engineering is the discipline of experimenting on distributed systems in order to build confidence in the system's ability to withstand turbulent conditions. This definition, this inherent proposal is really what got me thinking, right? Turbulent conditions, for my folks out there that are watching, that are viewing this, that are in information security, can resonate with the fact that the way we have to get so many things right, and the attacker only has to really get one thing right. And the way in which we have to respond to that is somewhat turbulent. There's so many unknowns. And so that's kind of our premise here, our backdrop. So what I'm proposing, as well as the chaos engineering community proposes, is that think differently about your systems. If failure inherently exists in your systems, no matter how many times you fix it, no matter how much effort you put into it, or whatever new capability you provide to it, every time you add something, every time you put something into the system, you're introducing possible failure, from human error to system glitches to unforeseen bugs, defects. It's to issues around the configuration and drift regarding that. But what we want to propose, if it ain't broke, don't fix it, is an old methodology, because it is broke. It's always broke. Whether it's the cracks you see at the top of the foundation, or it's those deep-ridden cracks that you see at the bottom that break the whole thing. We are trying to go at a deeper level of testing and failure here, because if it ain't broke, you need to be trying harder. Because if you're not instrumenting your failure, you're putting your systems at potential risk of someone else instrumenting your failure, and that being and the repercussions because of that. So a little history behind chaos engineering. So chaos engineering began as a discipline, as a testing methodology and functionality at Netflix. So many folks have probably heard of something called Chaos Monkey. Chaos Monkey was one of the original chaos engineering tools. It still is widely used, not only by Netflix, but the chaos engineering community. Netflix has, since Chaos Monkey, developed several other chaos engineering tools. If you see here on this slide, you'll see, a sort of representation of the Simian Army, is what Netflix calls its series of tools. You see Chaos Monkey, but you also see Chaos Kong and Chaos Gorilla. The difference is that what Netflix does, Netflix's chaos engineering tools are focused primarily on resiliency and driving new information about how their systems respond to failure. And so whether it be from bringing down virtual machine instances randomly, chaotically, or bringing down entire availability zones and seeing how things react, or even going even further, bringing down a region. So also another important distinction here is I get the question a lot, is that, well, isn't Security Monkey a security chaos testing tool? Well, Security Monkey really is a configuration validation policy engine for Amazon. It's more about validating good secure configurations. It's a great tool, but it's often confused as being a chaos tool. So that's a clear distinction to make. So let's talk now. Let's move a little bit into failure, right? Failure happens. We talked about this a little already. Is that, whether it's the most recent breach, the number of breaches with Equifax, or it'd be the next breach. Everyone is exposed to failure, whether it be yourself, the company you work for, or the systems you design or build or manage. And it's our job to continually instrument the failure and drive out the assumptions in our designs to ensure that our systems truly can withstand turbulent conditions and are rugged. So let's talk about real failure, right? So if you're not familiar with the Ponemon Institute, the Ponemon report, Ponemon produces a series of reports yearly around causes of data breaches and the value of records and how long it takes to respond to data breaches. It's really a great report. There's a number of other great industry reports, but I chose this one to sort of talk a bit about where failure comes from. So I want you to focus on the left part of this pie chart here, the gray part. Is you see 47% of our data breaches, our recent data breach data has come back as being from malicious and criminal attacks, right? This area in particular is where the majority of our security controls, practices, and technologies really target. It's actually the sexiest part of security. The malicious criminal attacks, the spy versus spy. It gets that sort of it has that sort of context and to it that people resonate with. But really, I want to take a look at the other two parts of the pie graph. If you look at it, human error in system glitches actually represent the larger half, 53% of where data breaches are caused from. And what we're trying to focus on is these other two. We're not trying to be perfect about it. We're trying to drive out failure and understand it, and so that we can fix it before it causes harm. So this little chart, this little slide is sort of just a representation of the different types of failure that do occur. Now, in the world of distributed systems, it is becoming more and more impossible really to understand all the pieces of the puzzle. The reliance on many different external APIs, external systems for data connections, failure can be introduced from all different kinds of angles, whether it be misconfiguration, whether it be code quality or defects. Like I said earlier, defense in depth could have control coverage gaps. Just because you have a control doesn't mean you placed it correctly, doesn't mean it's configured correctly, doesn't mean it's integrated well with the design. It doesn't mean it doesn't mean that you don't have failure there. It's often single points of failure can occur with that. If that control's down, does it bring the whole? If the control itself brings down the rest of the application, if it fails, that's not a very effective control. We need to instrument our failure and figure these things out, what works, what doesn't, before it impacts our customers through our products and services we offer. That's what we're doing here. So you'll see also that really some of the main areas that we're driving at here are the complexity in distributed systems, common misconfiguration, and human error. So let's dive deeper here. So this is a common theme, and I believe I stole this from Bruce Wong, who was formerly of Netflix and Twilio and now at Stitch Fix. Hope is not a strategy. That's why we have to instrument. We have to test. We have to be finding new ways to drive out this information so we can respond to it quicker. So now what I want to do is I want to talk to you about a security chaos experiment. So when we were developing ChaoSlingr, we went from inner source to open source in 7 weeks. Sort of a very movement-like effort around it. But as part of developing the tool, we decided that we wanted to have a marquee sort of experiment to start with that was people could easily resonate with, that people easily understood kind of the concepts of what we're trying to drive at. So we have this. So our marquee sort of security chaos experiment is port slinger. It's the idea of introducing an unauthorized port change into a system to understand where in the tool chain are we effective, where is it breaking down, where does the failure reside. Now, with ChaoSlingr, and I'll go more into the product and how it works and the the chaos experiments themselves. But ChaoSlingr is designed with the intention to have tens to hundreds of experiments to pick from and drive and be able to test your system chaotically with those different experiments and drive out new information. Now, to give you a backdrop of what the chaos experiments intend to do, okay, is that chaos experiments and chaos testing in general is not seeking to validate something we already know to be true or something we already know to be false. Meaning, we're not trying to, if we know there's not a firewall there and we know we're not going to catch an unauthorized port change, what is the value of testing that, right? So what we're trying to do is introduce common misconfiguration in secure settings, basically challenge the assumptions of what we based the firewall on to begin with. I'm just using a firewall as one example of many. The firewall is provided as an example because of an unauthorized port change. We assume the firewalls can catch these sort of things, block them, but let's not just assume it. Let's test it. Let's instrument it. Let's find new ways to instrument it, and that's what we're going to walk through this simple example with. So as part, so PortSlinger. So essentially what it does is it randomly selects amongst a bunch of amongst your AWS instance accounts the EC2 lists the available EC2 VPC security groups within the accounts, and it selects only the security groups that are tagged with an opt-in tag. Now, most of your chaos engineering tools have an opt-in, opt-out model. And what does that mean? What that means is that just breaking stuff for the sake of breaking stuff doesn't make anybody any better, or it doesn't drive quality. What we are trying to do, so what the idea of an opt-in, opt-out model is that certain things, depending upon the risk aversity of the organization, certain pieces of your design you may not want to expose to chaos testing. Right? Let's say, for example, that you didn't want the unauthorized port change to be instrumented on the edge of the application in Amazon. That is your choice. But there's also comes with the precursor of the warning that if you're not testing that somebody else will be, right? So if you need to test your security before your adversary does, okay? Let's get back to this. So it selects all the available EC2 VPC groups. It selects the security groups that are tagged with the opt-in tag. It could be anything from a random variable to text. It's just a resource tag. So randomly selects within the security group within the opt-in model pool, and then it will randomly open or close a port. So based upon the existing port configuration, so we'll check to see what ports are opened, and it will randomly open or close a port. Now that right there. So when that happens, and this is why this is sort of the context around the experiment. So when that happens, about 15 different sets of fireworks should be going off on your security controls. If your firewall, first and foremost, should be able to catch it, log an alert, log an event, throw an alert, and possibly block the change. If that didn't happen, did the configuration management tools in Amazon were they able to catch it? Right? Did they log data? Did they throw an alert? Did all the log data make it to the SIEM or your log aggregation tool? Was your log aggregation tool able to throw an alert to the Security Operations Center, the SOC? Was the SOC able to did they have enough contextual information about the alert through the process to begin the first tier of security incident response? Was security incident response, if you see where I'm going with this, we're going through the security control point of this simple example. And where in our process is it working? So was the configuration tool more effective, or was the firewall? Did the firewall do it? Was the firewall performing as we expected? That's still good information. But imagine a world where you have thousands of Amazon EC2 instances. There can be all kinds of, just because you're able to get right in one instant doesn't mean doesn't mean you get it right in all of the other instances. It could be a difference in how you place the control. It could be that you weren't able to implement the control the same way because of some anomaly or nuance in the application, and maybe you had to provide compensating controls. Now, there's another area where we provide a lot of assumptions. When I've noticed throughout my career that we provide compensating controls in the event that we feel that, we assume that these compensating measures can actually provide the same level of security as the primary control. But often I find that's not really the case. But let's instrument that. Let's find out maybe actually some of the compensating controls are operating better. But let's not operate on assumption. Let's test. That's kind of what we're coming at here. So it's important that we do this stuff chaotically and randomly throughout our system and throughout the control plane and drive out where that failure sits and fix it ahead of time. So here's sort of a general representation of a sample Amazon design where you would see, you could opt in different parts of your design and opt out others. So we're in the tool chain till we fail to succeed, right? Remember, we're not validating something we already know to be true or something we know to be false. Meaning, if we know there's no firewall, what's the point in testing for, a chaos experiment that we know won't work, right? What we're trying to do is test the assumption we already have in place and drive out info. We're not just trying to test, let's say, the firewall in this case, right? We're trying to drive out the full tool chain, right? We're looking at the whole chain because we don't realize, or at least this has been my experience throughout my career, is that most organizations don't realize something didn't work until it didn't work. That is, until, in this case would be in a security incident, right? Is that we don't realize our controls were ineffective until there's a security incident. That is not a detective measure. That is not the time you want to find out something didn't work, right? We need to be proactively testing the tool chain. And I've often found in working in security and response in my past is that a lot of times the data is the context around the event, is there's a lot of false positives. There's a lot of false positives. There's a lot of actually, legitimate events that you just can't really discern well because we focus so much on control. We didn't focus whether or not the assumptions around the control were effective, like that it actually throws good log data to as part of the event so you can actually do incident response. So that what we're proposing is trying to provide the measurement into those actual controls. An important distinction too with ChaoSlingr is that we feel that this data that we are producing with the tool, or if you use it with your organization, that the data over time represents a level of maturity around how we're building in security, how certain app teams are implementing, our DevOps teams are implementing their security on their applications, right? Were they able to, if they consistently see app team A keep showing up that, the different applications that they manage, that they keep missing certain types of configurations, that may be an indicator of maturity and that there needs to be additional training, or maybe there's something else more systemically going wrong there, right? So that's also an important thing to talk about, is that if you couldn't detect a simple unauthorized port change, there may be other things wrong, right, with the system. So that these not only is the testing valuable, but as a measurement and as a maturity matrix, it starts to get interesting. So, like I said before, don't let security incidents be your detective measures, right? It's too late by then, right? So we need to be testing more proactively and instrumenting and stop operating on assumptions. So, okay, so for the techies in the group, okay, they want to know what's under the hood. Okay, what's this thing all about, right? So let's get into that. So a little bit about ChaoSlingr. So when we developed this tool, we actually began with aligning with Chaos Monkey and Netflix's chaos engineering doctrine. There's a great book out there written by Casey Rosenthal Nora Jones at Netflix, and a few other folks about chaos engineering and how it works. I think it's readily and freely available through O'Reilly. It's a great book. I highly recommend it. But we strive to stay as close as possible to their doctrine to ensure that we could drive out the same level of value. And so we started originally with Chaos Monkey, and we started looking at the construct of how the tool was written. It was written in Go. It's got some other components like Spinnaker, which is sort of a pipeline type of capability. And we sort of started making the decision that, if Netflix had started designing this tool today, they may not have needed all of those things. And we decided we were able to ascertain that the pieces we needed to effectively run the tool could all be ran natively in Amazon. From the way the tool is scheduled to how it executes to how we store the data, all that. So we chose to develop the tool with Amazon's Lambda. And so the app is 100% serverless, probably serverless in AWS. We have configured multiple different operational modes and frequencies. So we have configured the tool to either be ran by, if your organization has a system reliability engineer or a chaos engineering team, we have sort of written the tool with the mindset that you may, a team of chaos engineers may want to do game days or run this as a service. We also ran it. We also envisioned it with an app team in mind that wanted to proactively test their instances. So it can be ran either ad hoc or scheduled, or as often as you want. Like I mentioned earlier, there's an opt-in, opt-out model. It's a very common feature of chaos engineering tools for the simple purpose of controlling the failure domain. Is that like I said, just blowing stuff up doesn't help anyone get any better, right? So, so let's see. So we've also built a ChatOps integration with Slack. We chose Slack because it's a very commonly accepted ChatOps tool. But our ChatOps integration was built for the purpose of the fact that if a chaos engineering team or someone running the tool would not really want to get a bunch of emails about the tool and how it was running, but they may want to actually collaborate on the different types of events and data coming back. So we decided to throw the data and events into Slack. So you could start threading different types of events and work through them as you feel is appropriate. The configuration for MVP for the tool was written with configuration as code as Terraform. So that allows you to get up and running with the tool quickly. We started with Terraform because that's the primarily tool that we're familiar with and use with in United Health Group. But we plan to provide additional type of configuration as code capabilities later. Also, a key part of the tool is the open, extensible chaos experiment. So a chaos experiment framework. It's a framework that I'm going to talk about here in a second of how you build a chaos experiment with ChaoSlingr. There's recently a standardized framework for chaos engineering experiments release called the Chaos Toolkit. We plan to work on integrations with in the future to alignment there, so we don't cause confusion in the chaos community. But we have our own framework for now, and we're really actually looking for feedback and additional experiments to be written. We've got a couple in the pipeline for an S3 bucket due to the number of data breaches. We've got an experiment with there. We've got another one with malware beaconing. There's several different experiments in that one. So that's roughly that. Let's talk a bit about the Open Extensible framework. So our Open Extensible chaos experiment framework consists of predominantly three Lambda functions. Predominantly, ChaoSlingr in general is what we call a pile of Lambda functions. Okay, so Lambda functions, if you're not familiar with them, are really just consider them as workers. Like they have one job and they do their job, right? And so these are 3 different workers that are organized around performing one set of experiment activities. So here's our example with PortSlingr. PortSlingr, remember, is just one chaos experiment, and we're explaining the various context around security chaos testing through this example. So in this example, Slingr is one of our most important aspects. Slingr is actually the thing making the change in this case, to the security group making the port change. Generator. So what generator is generator is the piece that actually starts the experiment and goes out and does target acquisition and we'll find out what port range is available to be opened or closed. Tracker is the piece that sort of tracks and discovers the changes and monitors and does the monitors and notifications for the tool. I will also add that there's a 4th piece here. If you're going to write your own experiment, that we highly encourage and we'd like to see is documentation. So an MD file, markdown file that describes sort of what your experiment does and how it works, just so people can know how to use it effectively. So what's next? So now that sort of talked about chaos engineering, security chaos engineering, what we're doing, how the open extensible framework works. We have a lot of planned ideas. We would like to really focus on the data component out of the tool. That was not a primary focus for the initial release, but since meeting with the Netflix team recently, they mentioned that that's a very valuable thing to have as part of the tool, is to ensure that we can accurately track what happened, right? That data has value over time, like I said, as a maturity, from a maturity perspective. So that is what we call the reporter functionality, is that it stores the data. We can look at it. We can report on it. We can do notifications based on it. That is a key part that we really want to focus on. We're also working on building community, really trying to, like I said, we released MVP to the world to be the foundation of which we could build a community-driven product, right? This is not just a health group or Optum product. That we want this to be something that we work on this with the community, right? Think of this as a proposal for something greater, right? Is that we want what we're looking for, like I said, is more examples of experiments, and sort of we've had some very interesting ideas, and it's really already been valuable for the community. But we're trying to get a good library of experiments in the open source repo. And remember that repo is github.com, and if you go to github.com, you can search ChaoSlingr, and you'll find it right there. And if there's any questions, you can email me, or my contact information I'll put up in a minute. We'd also like to try combining experiments, because if you think about indicators of compromise, an unauthorized port change, so let's use that example again, is that it's not often just one thing that is the indicator of compromise. Maybe it's a couple different things. Maybe it's an unauthorized port change and an unauthorized permission change, for example. Just off the top of my head, we would like to try combining experiments as part of future functionality, a roadmap technology. But again, you have to consider the failure domain and ensure that you're not just blowing things up to breaking things just to break them. We're trying to build in a kill switch. So we want in the event of an active incident going on, let's say there's a P1 security incident, right, that's going on. We want to be able to kill the tool and rule it out, and while incident response and different folks have a chance to fix things without us causing noise in the enterprise in the tool. So kill switches would kill the tool from running entirely. We'd also like to explore, the idea of a GUI interface, some feedback on the tool, maybe the health of where it's running, how it's running, how many times it's ran, sort of some metrics around the tool, think of dashboard. Right now, the tool is probably just code, right? It is just code running. It's Lambda, it's serverless, but we'd like, several folks have talked about the idea of having a GUI for those health check type purposes and operational metrics. So really looking for the community to also define what's next. These are just examples of what we'd like to see. And I'll leave with a couple parting thoughts here, is that security must be tested. And if you're not testing and instrumenting your security and operating on assumptions, somebody else is bound to test your security for you. And the bad part about that is that that may impact your customers in the wrong way when it comes to your products and services. So thank you very much for hearing me out. And I guess it's time for Q&A. Do you suggest we move away from preventative mechanisms and put more attention on pen testing? Well, so that's a really good question. So what I'm suggesting is not necessarily, I think we can't lose focus on the preventative. But I think what we have to do is, so pen testing is often too narrow of a topic. If we could provide that narrow depth in everything we do, that would be great. But like I find often that pen testing gets limited down to, whether it be how often you do the pen testing, whether it be you do it annually, quarterly, or let's say you're a Red Team Monday kind of company where you're doing red teams every Monday. But often that is limited to like critical business applications only, right? Or it's like, there's only so much pen testing you can do due to the nature and the depth of it. Like what I'm suggesting is a new way of instrumenting assumptions, right, around the preventative controls we're putting in place. And it's not just about like, were we able to get in? That's not really what we're going after here. What we're going after is the whole tool chain, right? Is trying to, trying to find out. Let's not just talk about the control itself. Let's talk about the incident response process, right? The contextual value of the data, right? Looking at it from their perspective, were they able to, if we didn't, were the events around the security incident, was that event data valuable? Were they able to quickly get to the answer? It's about testing those assumptions, but we're not testing just the assumption, test the assumption. We're trying to drive new information.